Okay, so based off of the last lesson, here's what you need to know, okay? Sine inverse and tangent inverse are both going to have the same domain. Okay, so their domain was from negative pi over 2 to pi over 2, okay? So meaning that the range, not the range, that's the domain, the domain. Domain. Oh man. Okay, I can't talk today. Just like in real life. All right. So the range for sine inverse and tangent inverse is going to be from negative pi over 2 to pi over 2. And this will make sense as we get closer, okay, to the next portion of the lesson. All right, so basically what you need to understand is if I'm solving a problem that involves sine inverse or tangent inverse, the only values of the unit circle that my answers can be are between these two values, okay? So remember that this is 0, and negative angles are created by moving clockwise in the circle. So this is negative pi over 2. And then if I were to move here, I'd go from negative pi over 2 to 0. And then up here, I would be at pi over 2. Okay, so sine inverse and tangent inverse can only have answers that are on the right side of the unit circle. Okay, so remember that all students take calculus. Okay. If I'm only looking at this side of the unit circle, then when I'm in the first quadrant, all of my answers are going to be positive up here. Okay, my trig values are going to be positive. And when I'm down here, cosine is the only thing that is positive, which means that sine and tangent are both going to be negative down here in this quadrant. Okay, this will make sense in a minute when I start doing some examples. Okay, cosine inverse was a little bit different though. Cosine inverse had a different domain and range. So the range of cosine inverse ends up being 0 to pi because that was the domain that we had to restrict cosine to in order for it to pass the horizontal line test. So if I'm looking at the unit circle, I know here is 0. I move all the way over here, I'm at pi. So that means that values for cosine inverse have to be between 0 and pi. Okay, so again, all students take calculus. If I'm looking at cosine, when I'm in this quadrant, all of my cosine trig values are going to be positive. And when I'm over here, S means sine is positive. And because I'm talking about cosine, obviously cosine is going to be negative. Okay, so basically now what you need to understand is does sine inverse mean? Okay, what is it asking you? So really important, okay, to reiterate is that this does not mean cosecant of x. So remember, cosecant is the reciprocal of sine, okay? And when we have something that's being raised to a -1 power, that normally would mean to flip it, right? So if I had 2 to the -1, that would tell me to do the reciprocal. That's not what that -1 is. The -1 is not a power, okay? That -1 means inverse. Okay, so if I'm asking you for sine inverse, this is what I'm asking you. It means find the radian value. Radian meaning in terms of pi. Within the allowed region that gives us theta. That gives us x, not theta, as the trig value. Okay, so I'm asking you to find an angle. Find the radian value, which is an angle, or theta. Find theta within the allowed region that gives you x as the trig value. Okay, so I'm going to ask you kind of backwards. What angle has a sine value of 1/2? Something like that. Okay, so here's another way to think about it using that idea that in an inverse function, x and y are switching. Okay, so if I normally would say sine of x is equal to a trig value, x would be my angle, right? Okay, sine of x is equal to a trig value. The trig value is like my y, that's my answer. Well, then in sine inverse, these two values are switching. Okay, so sine inverse of a trig value needs to equal the angle, x, or the angle. Okay, so again, I'm going to ask you what angle has this trig value for sine. Okay, so we'll do some examples. Okay, so our first example would look something like this. So here's cosine inverse of 0. Okay, so this is actually asking me, where is cosine equal to 0? Okay, or what angle has a cosine value equal to 0? Okay, that's what I need to be thinking about. So cosine inverse equals 0. There's multiple angles where cosine is equal to 0. So here's what we have to be careful about. Okay, so normally we start here at 0, right? Here's pi. So cosine of 0 is 1 because that's the x value. Cosine of pi over 2 is 0. So pi over 2 is one of our options. Okay. And then if I keep going here, cosine of pi would be -1. Cosine of 3 pi over 2 would also be 0. Okay. And then I could continue going around the circle, right? As soon as I hit this, this would be 5 pi over 2, and then again at 7 pi over 2, and so on and so forth. But here's the key that you have to remember about what we talked about on the previous little whiteboard or lesson even, okay, that cosine inverse, in order for cosine inverse to exist, it was only defined in the top half of the circle. Okay, so it's only defined from 0 to pi. So even though cosine of 0 or cosine of 3 pi over 2 is 0, 3 pi over 2 is not in the top half of the unit circle, so it is not included. And that means that pi over 2 is the only answer to that problem. Okay, so here's another example. Sometimes the value will be given to you in parentheses like this. Okay, on the last one it wasn't. In this case it is because I have this negative. So just know that you'll see it either way. Okay, so sine inverse of -1/2. Okay, so again, this is what I want to think about. What angle has a sine value equal to -1/2? Okay, so if I'm looking at the unit circle, remember that sine inverse only exists on the right side of the unit circle, okay, from here to here. So we're calling this negative pi over 2. This would be 0. This is positive pi over 2, okay? And I want where sine is negative. So in quadrant 1, everything's positive. Down here, cosine is the only thing that's positive. So that means I want the angle that is down here. Okay, now normally if we were going all the way from 0 around the unit circle, this would be 11 pi over 6, okay, just shy of 2 pi. But I'm not allowed to use this side of the unit circle, so I can't think of this in terms of 11 pi over 6. Instead, I have to think of it in terms of a negative angle. So any angle down here is going to be negative. It's actually kind of easy because over here we know we would have positive pi over 6, positive pi over 4, positive pi over 3, positive pi over 2. So in this direction, I'm just going to have negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. So pi over 6 is usually the angle that has a sine value of +1/2, but since I'm down here, it's going to be negative pi over 6. So that would be the angle that has that sine value. Okay, here's another one. Now this is important. Arctan of √3 of √3. Okay, so arctan is another way to say tangent inverse. Okay, it's the same thing. It's two different ways. Sometimes this notation is not helpful or it looks kind of funny. And so arctan is another way that we abbreviate tangent inverse. Just know these are the exact same thing. Okay, so if you see this on your homework or any other problem moving forward, arctan is the same thing as tangent inverse. Okay, so I want to know where or what angle, okay, what angle has a tangent value of √3. All right, so we look at our unit circle. Arctan or tangent inverse follows the same rules as sine inverse. So again, I can only use this side of the unit circle. So my options are from negative pi over 2 to pi over 2. Okay, now what I need to remember is what angle has that value. So first off, I know this is all, and this is C. So here's where I'm going to be positive. This is a positive √3, so I know I have to be in the first quadrant. And then I have to remember tangent of what angle has the value √3. Well, the answer is pi over 3. Okay, so pi over 3 is the angle whose tangent value is √3. So if I asked you, what is tangent of pi over 3? You tell me √3. Okay, remember that tangent of pi over 6, oops, slide my board up real quick, okay, is equal to √3 over 3, because remember that the two 3's make the 6. Okay, so that's one of those little memorization tricks we use. So tangent of pi over 3 is equal to root 3. So arctan of root 3 is equal to pi over 3.